All right, everyone, we're going to go ahead and get started and hope others will join us shortly. I'm Judy with the Northwest Gas Association. This month's webinar, Carbon Management and Decarbonization, is with GTI's Daniel Lefevers, Director of State and Consumer Affairs. And I just want to remind you also that the microphones are muted. We are recording this. It'll be on our YouTube channel later today. You can download it and share it with other guests from there. And just next month, we're going to have another webinar on April 17th, Building for Efficiency with the American Gas Association. So be sure to register for that. And also the annual energy conference registration is open, and you can access that by going to our website and scrolling down on the front page, and you will see a link to register. And with that, Dan, I will turn it over to you.
Thank you, Judy. I really appreciate the invitation to present to the Northwest Gas Association. Hopefully most of you know GTI, formerly Gas Technology Institute, now just GTI Energy. We've worked with many of your members for decades, so I'll talk a little bit about that today. But most I'm going to focus on some of the work that we're doing around decarbonization and some of the analysis and information that we've been sharing with others. Most of what you're going to see today has been presented as part of the Future of Gas proceeding in Illinois. Um, if any of you are interested, they record and provide all the information that's come out of the Illinois Future of Gas proceeding. And if you just go to your Google search engine and put in Illinois Future of Gas, it'll take you to their website. And you can look at every presentation, you can watch every workshop, and any comments that were made by organizations. So really great wealth of information. So just a little bit of background on who we are. We have about 500 employees total through the enterprise. We do have some for-profit subsidiaries in the energy space. Probably the largest that you may be familiar with is Frontier. They're mostly working on energy efficiency projects across the country. We have been nominated the top workplace by the Chicago Tribune for since 2019, which is great. And some of our collaborative R&D programs you may be familiar with are OTD, UTD, and the Low Carbon Resources Initiative, which is a partnership between GTI Energy and EPRI. Operations Technology Development and Utilization Technology Development are two programs that are usually almost exclusively funded by ratepayers across the country. And those funds are distributed and managed by a group of utilities that decide on what projects get funded. And I know many of the people on the phone today have been engaged or involved with those programs. I want to level set the energy system today because whenever I talk about decarbonization, you'll run into folks that say, oh, well, we can just, wave a magic wand and create more electricity and, it's going to be great. And, it's all going to work wonderfully. But I think many folks, not the people on the phone necessarily, don't understand the complexity of our energy system and kind of what makes it up. So you're looking at 2020. It's not very different today, other than, well, I'll show you here. That shows wind and solar. That probably has about doubled since 2020 for the electricity sector nationally. Gas has also grown. So that gas-fired piece you see now, that also has grown. There's more gas-fired power generation now than there was in 2020. And I think most people are aware that last year, on one specific day, we used more natural gas than ever in the history of our United States. So natural gas plays a huge role in our energy system. And I want to talk about an interesting aspect of our gas system that doesn't get talked about a lot. But when we think about decarbonization and what it might look like in the future, and if we're going to make replacements or change things around, one thing we have to remember is the unbelievable, huge energy storage capability of our natural gas system as well as our liquid fuel system. Both of these systems have 7 to 8 weeks of storage capacity that would be able to run what we do every day for 7 to 8 weeks. So it's, that is an amazing aspect of our current energy system. And as we have any thoughts about what we're going to do in the future, we really need to keep those two issues in mind and understand that there's great value and flexibility in having that kind of storage capability for energy. So what does today's energy system look like? You got sources on the left. You make electricity. A lot of these sources like natural gas and petroleum get processed in some way and go right to end use. But that's what it looks like today. And there could be a lot of different new aspects of this in the future. And I'll talk about that in a bit. So we did this meta-analysis of the U.S. economy-wide studies. This was done by GTI, but it's actually a compilation or a synergistic view of all 5 studies. These are the 5 studies, and that's why it's called a meta-analysis. Low Carbon Resources Initiative, and that was done by EPRI and GTI Energy. Open Energy Outlook, Carnegie Mellon and NC State. Evolved Energy Research there in California, you may be familiar with them. Princeton University and something called Decarb America out of the Bipartisan Policy Center. What all 23 scenarios of these 5 studies showed that in every net zero 2050 scenario, other than 3 where they eliminated the use of fossil fuels up front, all the scenarios led down a pathway where we still used low carbon fuels, pipeline gas, existing infrastructure. We did have expanded electrification and more renewable energy. And what it kind of looks like in the future, based on that analysis, is we're going to have a lot different types of energy resources and energy providers that will look a lot more complicated than it does today, potentially, particularly in a net zero energy system makeup. So we're going to have a variety in electricity, a variety in fuels, plus carbon management and efficiency. And those are really the 4 pillars to get to net zero in 2050. And why do we still use pipeline gas in the future? Well, because we have 3 million miles of pipelines and it's a great way to move energy. But of course, in the future, pipeline gas may not all just be natural gas. It could include hydrogen or renewable natural gas or other low carbon synthetic fuels. So pipeline gas is used in every net zero scenario. And gas infrastructure peak throughout remains because there will always be these days where you're going to need more molecules for whatever specific reason in our energy system. Might be weather, could be something else. And again, we have 3 million miles of gas pipelines, 8 weeks of storage. And today, gas underpins about 1/3 of our total final end-use energy consumption. So those values and the current system can be utilized to help move into decarbonization and retaining those values for the entire energy system that we have in the future. And I think this is very interesting when we look at those net zero runs that they did, the 23 of them. In all those scenarios, about 60% of the energy consumed in the future is still liquid fuels and pipeline gas. So obviously we need to use different fuels, that some of them are mentioned on the bottom, and carbon sequestration and carbon management was a big part of those scenarios also. I think this is kind of just repeating what I said earlier, but carbon capture is important, carbon dioxide removal, and of course, low carbon molecules are blended in the gas supply in all these scenarios. So you can go to GTI Energy Meta NZ and look up that analysis. We're going to be doing a new analysis next year. So we'll find additional studies that have been done, modeling studies, looking at net zero and kind of gel those together and provide you the findings in a report next year. So I want to talk a little bit about how we can decarbonize pipeline gas. I think there's 2 scenarios that you probably are pretty familiar with. One is hydrogen, and one is renewable natural gas. So I'm going to talk first about renewable natural gas, which is probably the most common low carbon molecule that's put into the natural gas system today. As many of you know, it's mostly used in the transportation sector in California because of the value of the program run by CARB, Clean Fuels Program, California Air Resources Board program, and the credits that you can receive, and that lends itself to the gas moving via contract into California. Here's a little, this came from the Coalition for Renewable Natural Gas. It gives you an idea of the existing RNG facilities in the US. It's a growing area. There's a lot of interest in RNG in all sectors of the energy system. I mean, I talk to utilities all the time. They're interested in it, but so are companies making biofuels who want to use RNG so they can have a lower carbon intensity for the fuel that they're making. Obviously, still in transportation, there's interest. Companies that are big industrial companies that are looking to reduce their CI. So the growth of RNG continues, and the markets are going to expand. So there will be RNG produced in the future. Companies that are involved in developing RNG projects are healthy and profitable, and I think that the market looks strong for continued growth in this space. These are the sources of RNG in the United States: food waste, wastewater, ag waste, and MSW. Again, if you want information on RNG, there's a lot of good educational information, a lot of background information, studies about sources of or how much RNG we could make in the future. You can go to rngcoalition.com. You may remember this. I don't know how many of you were familiar with it back in 2019 when we published this report. But because GTI has developed a gasification technology over decades, we looked into what you would need to do to take an existing biomass power plant and turn it into RNG production. It was funded by those companies listed at the bottom, including Northwest Natural. And you can see where you can get that report. I bring this up because in addition to those sources that we saw on the slide before, you can use sources like wood waste. And so obviously with the fire issues in the Northwest and in California, there's conversations about, can we use wood resources to make fuels? Well, you can also make RNG through gasification from those wood wastes. And I'd like to talk about this a little bit. Somebody is actually building a large RNG facility that they've announced. This is Woodland Biofuels in Louisiana. It is likely, I won't say for sure because we're still having conversations with them, that they will use the technology that was developed at GTI Energy, the U-Gas technology, which is now offered by a company called Sun Gas Renewables and is a subsidiary of GTI Energy. But so this is starting to move now, and they're going to be producing, I want to say, I don't know if it's in this, but it's around 1 TCF a year, maybe 1.5 TCF a year. Is that right? No, I'm sorry, that's wrong. 3 BCF a year. I wanted to get it right. Yeah, so they're going to produce about 3 BCF a year of RNG. This is not known to everybody. Again, probably many of you on the phone know this, but when I talk to regulators or when I talk to, just people that are interested in RNG, they don't realize that you can buy RNG. You can go to a trading desk. You can go to BP, Shell, GTI Energy, other traders, and they'll buy you futures of RNG. So you can buy it. You can get 10-year contracts for it, just like you can buy regular natural gas. You can buy directly from producers. These are some of the companies that are out there, big companies with multitudes of projects. And the carbon intensity verification of the product can be part of the deal. So if you're a utility, you can go buy RNG, put it in your system, say how much that represents as far as percentage-wise, and talk about the CI score and blended CI scores with your system and how that lowers the overall carbon intensity. Now, obviously, this is a new area, and RNG, as some of you may know if you've looked into it, is quite a bit more expensive than regular natural gas. This is a chart about RNG carbon intensity. So this is from the California Air Resources Board and their the pathways in February 2023. as you can see, some of these pathways provide very, very low CI scores, carbon intensity, for the RNG provided. And I did want to show this because this is something, particularly when I talk to smaller utilities. I mean, there's utilities out there that could actually offset their entire carbon intensity of their entire system by purchasing RNG at certain CI scores. And so you can get a sense here. And the point here is really, when you look at this graph, is that yes, it can be expensive for RNG, but compared to what? What other strategies are you juxtaposing against using RNG, and what do they cost per ton of CO2 reduced? And so this chart kind of helps you think about it. If you were able to buy RNG of a certain CI score, you were able to buy it for a certain cost, you can calculate how much per ton does it cost to reduce CO2 emissions. And again, if you were to get a negative 60 CI score amount of, say, RNG 3 BCF, and you blended that with another 6 BCF of regular natural gas, you basically get 0 CI score for that 9 BCF of fuel that you're providing to the customer. So it does represent a means for the future when these kinds of scenarios may be required. This was a study done by AGA. I suspect some of you have seen this. But according to that study, RNG could reduce emissions from natural gas 95% in the residential sector. So this is, again, this is a real resource. It does exist. It can be purchased, and it is growing. Now I'm going to talk about hydrogen. Why hydrogen? It's abundant, makes up 75% of all matter. You can get ultra low, 0 emissions depending on the source of the kind of propulsion you use. Obviously, fuel cells, there's no emissions when you use a hydrogen fuel cell. You can use hydrogen in ICE engines and you still have some emissions, but not CO2 emissions. It's been used for 90 years. It can be used as safely as gasoline and natural gas. It does have different attributes, so you need to be aware of what those are. And of course, it's domestically produced from a variety of sources, but mainly it is produced from natural gas through a SMR, steam methane reformer. And that's about 99% of all the hydrogen produced in the United States today is produced in that manner. This is a chart talking about the potential cost for clean hydrogen per kilogram. I will say these are projections. Right now, I think if you talk to anybody in the clean hydrogen production space, they're going to tell you that it's probably at a minimum $5 to $7 without any kind of incentives. You may be aware that there is now a 45V tax credit for clean hydrogen production, which includes blue hydrogen, which is basically the way hydrogen is made today, but you sequester the carbon. And then there's green hydrogen, where you use electrolyzers and renewable energy, or pink hydrogen, which comes from utilizing nuclear power to produce it through electrolyzers. So there's a lot of different ways to produce it, a lot of different sources of energy that can produce it. So again, this is the beginning of the marketplace, and there are some activities going on right now with blending hydrogen into the systems across the United States. You can move hydrogen in different ways, pipelines, in tube trailers, or cryogenically, which these pictures show. These are the existing hydrogen pipelines today. Almost all these pipelines are moving hydrogen for industrial applications. In fact, I'd say no, all of them are. And the biggest application for hydrogen is in refineries. So most of these pipelines are providing hydrogen to refineries or some other heavy industries. And so as we think about the hydrogen in the future, can we use some of our existing natural gas pipelines and change them over to hydrogen? The answer is actually yes. In fact, parts of the pipeline in the Gulf Coast were originally natural gas, and they were changed over to hydrogen. Now these are, I'm talking about bigger pipelines. And there's a lot of issues, right? These are all the issues that will have to be considered if there's any of this going to happen across the United States. But these companies are smart companies. These pipeline companies have been around a long time. They understand hydrogen, and if in the future we need to move hydrogen in a larger manner, we may have the opportunity to use some of the existing infrastructure. So I hear this a lot from different folks when you talk about blending hydrogen in the gas grid. Oh, it's not safe. We've never done this before. My gosh, this is going to be dangerous for the customer. I mean, all kinds of different things. Well, I think what a lot of people don't know, or well, certainly wouldn't remember because it was so long ago, but in the 30s, 40s, and 50s, we used town gas in most of the cities, and some of that gas was up to 50% hydrogen that was going into people's homes. And today, Hawaii Gas, their product that they provide to homes is about 15% hydrogen. So blending hydrogen into a distribution system and utilizing it at low blends in existing natural gas technologies is something that we've been testing for years now. And we're working with a host of gas utilities. And there are other gas utilities that are working on their own to work on this and to think about it. So, and this gives you kind of some of the constituents of different kind of town gases that are used still today. But again, hydrogen-rich methane blends are used, have been used across the world and are still used in certain parts of the world. So some of the utilities are looking at blending. These are some of the companies that have blending demo projects. You can see some of the work that we're doing in our laboratories today. We're taking everything from a very small 2 to 5% blend and testing it in a major variety of technologies that you would use in your home. So everything from 5% all the way up to 40, 50, 70. And then obviously when you get to higher blends, you need different kind of burners and different kind of technologies. This is some of the work that's going on in Germany. I'm not Germany, I'm sorry, in the UK. And I guess look at the Utah projects here too. But again, opportunities for testing these systems on hydrogen. We manage a project called H2 at Scale in Texas and beyond. This is a project that really is like a mini hydrogen hub. And you can see all the different kind of applications that we're using hydrogen in as part of this project throughout Texas. And then you may be aware GTI Energy is involved with 3 hydrogen hubs. We do manage the high velocity hub, so we're the prime in Texas. And then we have projects within the Midwest Alliance for Clean Hydrogen and ARCH2. So this just kind of gives an overview of the kind of projects that we're involved with right now. But most of them are just addressing the issues around using hydrogen in the future in a different way than we use it today, which is basically just industrial applications, big industrial pipelines, cryogenic delivery. But looking at it, what if that was different and we were using it in more traditional methane applications? What do we need to figure out? What do we need to learn? What's the issues that we need to address? And that's the kind of work that we're doing. And we're working with all major manufacturers and different companies. Okay, thinking this there we go. So what are the initial findings of some of the work that we've done? And this is, these are blending projects that we've done at about up to 30%. And these are what we find. Cause equipment to immediately malfunction, improbable, lead to unsafe operating temperatures, adverse. So all of these things we've been looking at, I think, and a lot of them are very, very interesting because I think when we went into this, particularly on the emission side, we thought there might be some different, changes on the emission side, maybe more CO2 and the like. Not really. Again, we drew from 30 different studies, published testing data and results, as well as our own testing and results. So this is the interesting part about emissions. And what we really learned was that energy adjusted, it really doesn't change all that much in most of these technologies until you get to very much higher blends. So if you can see that most of these technologies they don't go down the same amount, right? If you put 30% hydrogen in with natural gas, you're not going to get 30% more NOx and CO. It doesn't work that way. So we have the study and these results. I think this was something that we were, very interested in, and we continue to do this testing today. And this is the other issue that was a little surprising. Again, when you blend hydrogen, and even though it's less energy dense, it isn't like if you put in the amount that you put in doesn't necessarily reduce the amount of energy output by the same percentage. And that's something else we need to think about. The reduction is not necessarily predictive to the percentage. All right. Just wanted to highlight some of the work that's being done in the hydrogen economy and industry investments that are going on across the full spectrum of different companies in this space. The big work is in burners and equipment, combustion controls. Those are going on not only for like end-use technologies, but also electricity producing technologies too. A lot of work in the industrial decarbonization space that we're involved with. So big, gigantic companies that use a lot of energy are looking at basically two ways to reduce their carbon intensity, where they need fuels, and one is back-end carbon capture with sequestration, but the other is using a cleaner fuel like hydrogen up front. And so we're working with them on some of these projects, particularly on burner design. Vehicles, you may be a little aware of the vehicles that are in the space right now, and we're supporting many of these projects around the country to demo heavy-duty trucks as well as locomotives. And we even have a project with hydrogen drones. This is just a big picture of a lot of work we're doing with EPRI in these spaces. And this is another point that I'd like to make that people don't always, when you talk to them, they say, oh, we need all these new codes and standards. We don't know what to do. It's hydrogen, but there is a lot of codes and standards already existing for hydrogen. They are being upgraded all the time, and there's activity in the space that natural gas utilities can get engaged with and participate in if they choose to. Now, I want to talk about some more of the traditional technology plays that you can utilize to reduce or you can decarbonize. I like to show this picture because it gives a good sense of how you can use these things in a stepped way, right? Higher efficiency gas equipment, hybrid systems, building envelope improvements. We can get the 25 to 50% reduction of carbon just in a building, right? If you do those things up. You can get another 40 to 60 potentially with heat pumps or micro CHP systems or deep building retrofits. And then of course you can blend renewable natural gas and other lower carbon fuels into your system. You can utilize solar on your roof or renewables in that way. So more of an integrated energy system in the home. Or you can lower methane emissions by utilizing lower carbon natural gas, which is being done by reducing methane emissions upstream. We are involved in all of this space, and we're developing technologies and analysis in all these areas. Wanted to mention Veritas. So this is our, it's a little difficult to explain when I talk about it, but the main goal of Veritas is to create a methodology and a reporting protocol that looks the same to everybody, so that, as an example, you're an upstream company, you have sites that are producing natural gas. What we're attempting to do here is to get everybody to use the same approach, not the same technologies, but the same reporting approach. It looks the same, and then folks can use it depending on whatever technologies they're utilizing, and it kind of interfaces with the EPA and the international bodies that are in this space, working to lower carbon methane emissions upstream. Another way to reduce emissions are using hybrid systems. So one of the fastest ways to make reductions in a building's carbon footprint is to replace the air conditioner with a electric heat pump, and utilize that for shoulder month heating. So these systems, most of these systems today are on and off, right? So your furnace, goes on at 35 degrees, and before that, your heat pump might provide the heat. Now systems are being developed with controls that actually both are working at the same time. So it's almost like the heat pump's providing preheat for the natural gas furnace. So all of this work is going on, but this is a very effective way to utilize existing infrastructure and making pretty big gains in carbon reductions, particularly when coupled with energy efficiency or building envelope improvements. Gas heat pumps. So we're developing gas heat pumps. We've tested, I think, every unit that's out there. There's multitudes of major demonstrations this year. And I want to say it's maybe 30 or 40 across the country, maybe even more. This is a very good technology, particularly in cold weather climates, because an outdoor unit utilizing natural gas can provide your hot water and the heat for your home, and will work just as good when it's 40 degrees out as when it's 30 below. So that's a great, it doesn't diminish the delivery of heat when it gets colder. It stays the same. Efficiency doesn't stay the same, but the delivery of the heat does. We're doing a lot of work in this space. I'm not going to go on all these projects, but obviously there is a lot of previous work that's been done in building retrofits and building improvements. There's a lot going on in this space right now, and it's very exciting. So as we build new buildings, they're going to become much more efficient, not just residential buildings, but all kinds of buildings. So the overall energy needed for these buildings will go down, and that's good, because we're going to have more buildings, so we can spread the use of our natural gas among more buildings that need less energy, and we can continue to reduce our carbon emissions. This is our microgrid test facility. It's very interesting. It utilizes a small DG unit produced by EC Power, I think is their name. They're out of Denmark, but they have built a business here in the United States now. It's about CARB certified. It'll be the only small DG unit running on natural gas that actually will be CARB certified for emissions, which is a big deal. But we utilize this system that has the MCHP power, solar PV, grid power, and we utilize the heat from the small CHP system, and we're able to dramatically lower the cost of energy for the building and get to almost zero for the emissions of the building. So in summary, the meta-ENSI analysis shows that gases and fuels will be used in 2050 in all the net zero scenarios. Natural gas is a very large portion of our nation's energy mix and is very important the way our systems work. Always like to point out that all decarbonization solutions have cost. And the question is, which ones will be most cost effective in the short, medium, and long term? How can they utilize existing infrastructure that's already built, which helps them be lower cost? And of course, continued analysis and R&D in that space is needed. And then this is just a list of some of the other decarbonization opportunities I talk about in the technology space. All right, that's all I have. I'm going to stop sharing.
Okay.
I don't know
Does
if
anybody have
yeah.
questions? You can unmute and ask questions if you have them, or type them in the chat, whichever you prefer to do.